All right, we're going to finish this up with part 3. So we just learned what a Hadley cell was. It's a massive convection current over the ocean. And it's important to know that Hadley cells occur at the equator. Now, what is so significant about the equator? It's the hottest location on the planet. So these are going to be very powerful convection currents because heat produces more energy. Okay? So they are strongest at the equator. All right, they're strongest at the equator because of the sun. All right, so they're going to be very intense here. Think about hurricane production. All right. So these are also, because they're so large, they're going to create global wind patterns. Remember that video or that image I showed you guys at the beginning of the units where it showed the wind blowing 2 different directions? That's because of Hadley cells. Okay. Now, let's look at this image right here. So this image is showing us what we call the Coriolis effect. And I mentioned this, I think, in the first video. So, when we're looking at the Coriolis effect, why does wind move in certain directions? Why is it different in the northern and the southern hemisphere when you have hurricane movement or toilets flushing? And it's all based on the rotation of the earth. Okay? So, let's just say, if I was standing right here, yeah, I know I put myself in the middle of the ocean, okay? And I threw a baseball. And I wanted to throw it to you. And I was throwing it in a straight line. And I would have you come stand over here. And I threw it. It's actually not going to go that direction. It's not going to go straight. Because the Earth's rotation, it would cause my throw to curve like this. And that's what we call the Coriolis effect. Okay? So, let's go back to the equator right here. Where does the Earth spin fastest is at the equator. And yes, that's a little bit more physics, right? But it directly impacts the way air pattern flows. Okay? So, the Earth spins fastest at the equator. Okay? So the equator, at this location, it causes deflection of winds. You guys are going to watch an Ed puzzle on the Coriolis effect, so you'll kind of understand how it pertains to hurricanes as well. All right. Let's look at the seasons. Now, you probably haven't talked about seasons since elementary school, but seasons are created based on the tilt of the Earth, okay? And it is directly dependent upon solar radiation, so sunlight. All right, so we can say that solar radiation which we also call insolation, solar radiation or insolation, is dependent on latitude, so how far up you are from the surface of the Earth, and seasons. So we know that in the winter and fall we have less sunlight. In the summer and spring we have more sunlight. Okay? So the tilt of the Earth, whoop, that is not how you spell tilt. No 2 T's, y'all. Let me erase. The tilt of the earth causes seasons. Right now we are in fall, right? Causes seasons and the amount of daylight. Okay, so we are in fall right now. So let's look right here. So September, this is going to be fall, winter, spring, summer. So these dates you see on here, those are the first days of each season. Okay, and it all depends on the position of, or the tilt of the earth. All right, so in the summer and spring seasons, so in the summer, we're going to be dividing this into hemispheres. Okay, remember the equator is going to be dividing it into hemispheres. In the summer, okay, it's hot because we're tilted closest to the earth. So in the summer seasons, the tilt of earth is toward the sun. So if you look right here in the hemisphere, guys, in the northern hemisphere, United States, our summer months are, June, July, August, September. We're tilted toward the sun. But if you look at the other half of the planet, the southern hemisphere, they're tilted away. So they're going to be in winter. So what we traditionally think of as winter is flipped in the southern hemisphere. So right here, it's going to be colder in those locations. In the winter, right here, here's North America, tilted away from the sun. So if it's winter, it's tilted away from the sun, which is why it's colder. So in December, if you were to go to Brazil, that's summertime, y'all. It's cold up here, it's warm down there. Okay? All right. So the last thing I want to look at with you is what we call El Nino. So we have El Nino and then we have its cousin La Nina. Okay? So basically this describes how the temperature in the ocean impacts the weather each year. Okay? These are collectively referred to as an ENSO. Let me write that down. ENSO. Okay, so what this stands for is El Nino Southern Oscillation. Okay, so we're looking at changing of the ocean temperature in the Pacific Ocean. We're just looking at the Pacific Ocean. Okay, so that's what these colors are going to indicate. All right, so changing ocean surface temperatures. So changing ocean surface temps in the Pacific Ocean. Okay, and what this does is it will impact global climate. So it's going to impact global rain, okay, wind, and ocean circulation. Okay, so let's look at the difference between these two. So we're going to start off with La Nina first. So just to give you an update on the current situations, we are currently in a La Nina year. Okay, they typically alternate every few years. So this year we are in a La Nina, which for us means we're going to have a warmer winter, unfortunately. Okay, so the ocean right here is cooler than normal. Look at the temperature. So red is going to be hot. So it's going to be cooler than normal. All right, so this is what happens in a La Nina. We have strengthened surface winds, and what they do is they push warm water west. Okay? They're pushing it west. So what this allows to happen is cold water to come up. So colder water rises. Okay? And what happens if colder water rises, the atmosphere dries out. So if the atmosphere dries out, that's going to reduce the amount of precipitation we have, which could be a negative impact. Okay? And it could also impact economic situations as well if we have droughts and things like that. Okay, so then let's look at El Nino. Last year was an El Nino event. So you can see the temperature difference between the two events. Okay? So an El Nino event is going to be warmer than normal. Okay? It's going to be warmer than normal. So it's going to be the exact opposite of a La Nina. So we have weakened surface temperatures. Weakened surface temperatures. So the warm water does not shift. Warm water does not shift. And so what this causes is more rain in the U.S. Okay? Because that warm air is being retained, it's going to allow those convection currents to keep continuing to process. Okay? All right, so we are ending up Unit 3 right here, which means that we're going to be having a test coming up. Okay? So make sure that you guys are working through the assignments in Canvas because it's going to help you understand these notes on a much deeper level. All right? You guys have a good day.